Hello everyone, I am Kiran from Sri Venkateswara College of Engineering, Bengaluru. Today I am going to discuss one of the topic in Mathematics for CSC Stream 2, that is vector line integration. Introduction to vector line integration. Vector line integration is a mathematical concept used to calculate the work done by a vector field along a curve. It is an important tool in physics and engineering to analyze systems with changing force or field. By integrating the dot product of the vector field and infinite decimal displacement along the curve, we can find total work done. Vector line integration is represented by line integral symbol, and it is an extension of regular integration to multiple dimensions. Line integrals and parameterization. Line integrals are calculated by integrating a scalar or vector function along a curve. Parameterization is the process of representing a curve as a function of single variable. The parametric equation x equals to f of t and y equals to g of t are commonly used to represent curves in two-dimensional space. Vector fields and vector line integrals. Vector fields assign a vector to each point in space representing a physical quantity such as force or velocity. Vector line integrals are used to calculate the work done by vector field along a curve. The line integral of a vector field f along a curve C is denoted as integral f dot c ds, that is differentiation with respect to s, where ds is the infinite decimal displacement vector. Evaluating vector line integrals. To evaluate a vector line integral, we must first parameterize the curve C. Next, we substitute the parameterized equation into the vector field f to obtain f of t. Then we calculate the dot product of f of t and the derivative of the parameterization and integrate the result over the curve. Types of vector line integrals. There are two types of vector line integrals, that is path dependent and path independent. Path dependent integrals depends on specific path taken between two points. Path independent integrals, also known as conservative integrals, only depend on the endpoints and are insensitive to the path taken. Line integrals in two dimensions. In two dimensions, a line integral calculates the work done by vector field along a curve in the xy plane. It is calculated by integrating the dot product of vector field and the tangent of the curve over the curve's parameterization. Line integrals in two dimensions can be evaluated using either the parametric form or the path independent form depending on the circumstances. Line integrals in three dimensions. In three dimensions, a line integral calculates the work done by a vector field along a curve in space. The line integral is computed similarly to the two-dimensional case, but with an additional component for the z-coordinate. It is important to choose an appropriate parameterization for the curve to ensure accurate calculations. Conservative field. A conservative field is a vector field where the line integral is independent of the path taken. We will discuss the properties of conservative field, including how to identify them and how to use them to calculate work and potential energy. Non-conservative field. Non-conservative field are vector field where the line integral is path independent. We will explore how to calculate work and circulation in a non-conservative field, including how to use the curve and stroke theorem. Fundamental theorem of line integrals. The fundamental theorem of line integral states that if a vector field f is conservative, then the line integral of f along any closed curve is 0. This theorem provides a criterion to determine if a vector field is conservative based on its line integral. Conservative vector fields have important applications in physics as conservative force and potential energies. Green's theorem. Green's theorem relates a line integral around a simple closed curve to a double integral over the region enclosed by the curve. It states that the line integral of the vector field around a curve is equal to the double integral of the curve of vector field over the region. Green's theorem is a powerful tool that simplifies the calculation of line integrals in certain cases. Formula is integral of L dx plus, that is line integral of L dx plus m dy equals to double integral of dou m by dou x minus dou L by dou y into dx dy, where the path integral is transversed counterclockwise along with c. Stokes theorem. Stokes' theorem relates a line integral around a closed curve to a surface integral over a surface bounded by the curve. It states that the line integral of a vector field around a closed curve is equal to the surface integral of the curl of the vector field over the surface. Stokes' theorem is a generalization of Green's theorem to the three-dimension, and it is useful for calculating line integrals in more complex scenarios. Examples of vector line integration. Example 1. Computing the work done by force field along a straight line segment. Example 2. Evaluating the circulation of magnetic field around a closed loop. Example 3. Calculating the flux of vector field through a closed surface. Applications of vector line integration. Vector line integration is widely used in physics, engineering, and applied mathematics. It is used to determine the circulation of magnetic field in electromagnetism. It is crucial for calculating work, circulation, flux, potential energies, and other physical quantities. Applications include fluid dynamics, electromagnetism, mechanics, and optimization problems. Limitations and challenges of vector line integration. Vector line integration may become complex when dealing with highly curved or irregular curves. Some vector fields may not be conservative, making the line integral path dependent. Accurate parameterization of curves and choosing appropriate paths are essential for obtaining meaningful results. Conclusion. Vector line integration is a powerful mathematical tool for analyzing vector fields along curves. It allows us to calculate work, circulation, flux, and potential energies in various fields. Understanding the principles and applications of vector line integration is crucial for solving real-world problems. Thank you. Thank you for watching this video.